Hello everyone and welcome to today's webinar on Creo Composite Design and Manufacturing. My name is Alan Thompson. I am the PDC Technical Manager here at LEAP Australia. I'm being joined today by Daniel Grobelaar and Ben Muston, two of our Senior Application Engineers, and we're going to be running through the new Creo Composites module in today's webinar. So just an agenda for today's webinar. So we'll just have a little bit of an introduction to the product itself. We're going to have a little bit of a look at the solution capabilities, all of the different bits and pieces that it can do. And then I'm going to hand over to Daniel, and he's going to run through a demonstration so you can see the software running live. Okay. Then we'll have a bit of a wrap up and some Q&A at the end. So let's talk about the Creo Composite Design and Manufacturing. Okay, so what is it? So CDM, or there's a Creo Composite Design Manufacturing Advanced module, CDMA. So it's basically an add-on extension to Creo Parametric that provides essentially specialized functionality to allow you to work with the design and manufacturing analysis of composite products. Okay, so it's all about composite design. So in terms of what composite design, okay, so this is really specifically around fiber reinforced polymer composites, okay, which are used. A lot of people on today's call who are doing this sort of work, so obviously very interested in this. Understand all the benefits of that around high strength, resistant to environmental and chemical corrosion. They're usually very lightweight, okay, so lower, better for fuel consumption, sustainability, all of that side of things. That high strength and resistance makes them quite durable and long lasting, and also in terms of the ability to create complex shapes, okay, with the ability to alter strength and stiffness by working with your different fiber directions. Okay, so lots of benefits to composites, which is why we're seeing them used in more and more industries. Okay, so basically where we're looking for strength and weight reduction with enhanced resistance. Okay, so aerospace being a very common one, automotive, energy production, the wind turbine blades that you're seeing here, you'll see in the presentation, boat building, marine, sports and recreation, transportation, plenty of other examples out there. Okay, so obviously a lot of interest in composites, and really that's what this module is to help address. Okay, so let's talk about the composites module and what the capabilities are. Okay, so it's really around supporting the composite design workflow. Okay, so the first step is modeling your design geometry. Okay, so we do that inside Creo. We've got all of our surfacing capabilities and everything else to define that shape. Okay, often at that stage, it's a good idea maybe to do some initial analysis, maybe to understand, where your areas of high stress might be. Okay, because that's where you might need to concentrate on the design process around those areas. Okay, when you're defining our plies. Okay, so we can then go off and define our different ply zone areas, maybe some mold layup surfaces as well. Okay, so all of that is essentially just sort of general Creo design and analysis. Okay, so if you're on the subscription licensing, right, you can do all of that there. You've got some simulation capabilities in there. We can define that geometry, all the rest of it. Okay. So where we add to that is now with the CDM or CDMA modules. Okay. So with that, we can then start to essentially start to define our actual ply definition. Okay. So we've got the zones defined, but now we can actually define our ply and core materials, layup surfaces, rosettes, and then start applying all of that to the different ply zones. Okay. We have a laminate manager inside Creo, which you can see there in the screenshot. We'll talk more about that in a little bit to help us basically visualize and manage all of those ply definitions. Okay. Then we can get into some of our simulation side of things. So that's things around draping simulation. So basically ensure that everything's going to work okay. We can see where there might be potential problem areas with the geometry they're working with. Okay, so we can start to use things like splicing and darting that's also available in there to help make sure that's going to fit. We can also take this into simulation tools, Creo Simulate, for example, to validate everything with all of that material information. Okay, so once we've done all of that that simulation, then we can actually produce our finished model. So that could be a solid laminate part with all of the mass properties that come from all of our ply materials. We also have all of our manufacturing information. So there's some tools there to very quickly and easily export out all of our flat patterns, DXF profiles we might be using for various cutting or profiling machines. And then also how we document all of that. Okay, so our ply book drawing, which we can create very quickly using some new template options that are available in Creo. So the idea is that Creo Composite Design and Manufacturing, it simplifies the design and manufacture of those composite products. Okay, so basically there's a whole bunch of design functionality inside there. Okay, so we can basically define all of that geometry that we need. We've got a whole bunch of simulation and analysis tools, and then finally, as I said, very fast preparation of our manufacturing delivery. Okay. So to talk about each of them in a little bit more detail, so on the design functionality side of things, okay. So obviously we've got Creo with all of its capabilities to design any kind of shape or complex geometry, okay. So now new in Creo 10 is a new curved chain loop creation tool that helps us to define our ply zone and ply definitions. Okay, so this is not part of Composites, it's part of core Creo. So it's available outside, but it's heavily used inside the composite side of things. Okay. Once we've got that geometry defined, now we can get into the creation of our plies. Okay, so defining and creating them. So we've got manual pliers or core pliers with that taper, which are generally much thicker. Okay, we have lots of options in terms of visualization of those. Okay, so we can define all of our different transitions. We can look at a cross section through our ply model with the ability to scale that up to see what it's actually going to look like, because obviously we are dealing with usually very, very thin sections of material. So scaling helps us better see what we're working with. As I said before, we've got a laminate manager, okay, that really helps to manage and organize all of those ply definitions. Okay, so it's automatically populated as we are defining plies and cores. We've got color coding to help identify laminates based on their material and orientation here in the screenshot. Okay, and we can customize that to show additional information that we might need that might be of interest to us. Okay. So once we've defined all of that, we then have the option to basically generate a full laminate solid. Okay, so that solid model represents basically the manufactured state, the finished product with all of the core and taper geometry. We can also generate an inner mold line quilt as well to capture the surface geometry for other things. So on the simulation and analysis side of things, okay, so as I said before, there is first simulation is around draping simulation. Okay, so we can analyze the ply material properties and the surface contour to basically go and fit that ply to the surface and work out the flattened shape of the ply. Okay, so the drape manager shows the status of each ply that we've got in our laminate. Pardon me. And basically shows where there might be potential problems. Okay, so so it might be based on angles, whatever the geometry might be. So we can see those sort of color-coded highlights when we're running those results. So everything green is great. If there's yellow or red, then we might have some problems inside there. Okay. It identifies things like fiber distortion as well inside there. Okay. So so the other thing that's important to note is that it's also includes underlying plies as well. Okay. When we're doing that draping, so it considers the context of each ply rather than just what's on top of the layup surface. Okay. So once we've defined everything, if we're happy with all of that, Then we can also do structural simulation. Okay, so we can take that data directly, the geometry directly into Creo Simulate and perform a structural analysis on that. If you're working with other simulation tools, we can also export that out using .mas or HDF5 formats. Things like ANSYS, which we've already internally at Leap, we've checked. Yep, we can bring that geometry into ANSYS, and off we go inside there as well if you're using that piece. And then lastly, on the design and manufacturing side of things, okay, so other options you've got there with the draping simulation, it can also identify where you might have exceeded your material properties, okay, so things like roll size warnings. So then we can start to look at whether we need to do splicing or darting. We've got options there for overlap and stagger to help with that, okay, and we can visualize all that in the cross sections that in the screenshots, and Daniel will show this in the demonstration. Okay, but then as I said earlier, a bunch of tools around getting that other manufacturing information. So very quick and easy export out of either DXF or DWG profiles that you use in your manufacturing equipment, and also the ability to create your ply book, a template-based drawing that can create literally the whole thing in seconds. Okay, so that's a little bit of an overview of what composite design manufacturing can do, but it's enough from me. It's time to get into the meat of things. So I'm going to hand over to Daniel, and he's going to show us a little bit of composites inside Creo 10.